So this last part of chapter 7, it's really just the same work solving, but it's some situations that I think can be a little tricky. Okay, so I'm going to just show you some examples so you know what to do if you come across a problem that has these little significant tricks to them, in my opinion. Okay, so here we have square root of 5x minus 2 equals 3 times the square root of 3x plus 10. What you're going to want to do here is get rid of those radicals. We have the radical on both sides, so we can do the same work as we did before. To cancel out a radical, you take a power. So I'm going to take the second power to both sides. Now, the trick here kind of is, yeah, that extra 3 out there. Remember, this whole side is going to be taken to the second power. So the radical part, that's easy, that cancels out. So over here, we have 5x minus 2. But on this side, that 3 also needs to be squared. 9, and now the radical cancels out, 3x plus 10. So you kind of have some extra work to do because now you have to do the distributive property over there. Okay? It's still a basic equation. This is something that we should be able to solve. 5x minus 2 equals 27x plus 90. Okay? And now it's just basic solving a linear equation. Bring the x's to one side, bring the constants to one side. If we do this, we would end up, if I subtract my 5, subtract my 90, you get negative 92 equals 22x. Negative 92 divided by 22 equals x. And to simplify this, I have it as 4.182. Oh, negative 4.182. Or you could simplify it, just simplify it as a fraction, which would end up being negative 46 over 11. So either one of those would be acceptable. Okay? So there's that first example. Okay? Now this one, same concept, but both radicals are on the same side. And you can't just add what's underneath the radical. You can't just add the radicand. So what I'm going to do, I'm going to bring this square root of 4x plus 4, I'm going to bring it over to the other side. And that's just doing basic math of whatever you do to one side, you have to do to the other. So they're going to end up over here canceling out, and we're going to be left with square root 9x minus 1 equals square root of 4x plus 4. And now it's just like the problem we had above, a square root on both sides. So I'm going to square both. 9x minus 1 equals 4x plus 4, because things are canceling out. And if you do the work to solve for x here, add your 1, subtract your 4, 5x equals 5, x equals 1. Sorry, I got a little low there, sideways. Okay? X equals 1 there. Okay? These were both examples of square roots. If they were both cube roots or both fourth roots, you would do that same thing just with the third power or the fourth power. They do need to be the same radical, though, the same index. If it was the cube root and the fifth root, you wouldn't be able to do it to both sides. So there's a couple other things we'd have to deal with that we're not going to do it in this course, but later on you may have to deal with that. Now we have x to the 3/5 equals 64. Okay? Now we have a fraction in our exponent. Now, there is ways of rewriting this that we haven't gone over yet. We actually go over that in 7.2. And after you see that, you might like that method a little better. I'm going to show you a little trick here that this is the way I like solving it. And I like solving it by taking the reciprocal of it. The reciprocal of that fraction would be 5 over 3. And if you do that power to both sides, that exponent's going to cancel out. 5 over 3, 5 over 3. And if you think about it, just remember the properties of exponents. When you have an exponent inside, outside parentheses, you multiply. Well, 3 over 5 times 5 over 3 is 1. That's how those exponents cancel out, and you're left with just x equals then. Okay? Now, when you're plugging this 64 to the 5/3 power in, take your time, and you're going to need to put parentheses around that 5/3 in most calculators. So just make sure you take your time plugging that in the way I have it up there. Now the other thing you're going to need to think about though, you do need to think about one or two answers. Okay? You look at the denominator. The denominator is going to determine that. If the denominator is odd, you get 1. Even, you would get 2. Since it's 5/3, 3 is odd. So just plug this in. We get one answer, and I have 1,024 as my answer. Okay, so again, you look at the denominator and decide odd and even. Even is 2, odd is 1. And we have 5x to the 2/3 plus 3 equals 23. Same work as before. Get x by itself. Okay, as you're getting x by itself, I'm going to subtract my 3. Divide by 5. And I have x to the 2/3 equals 4. So I'm going to take the reciprocal of that. This time my reciprocal is 3/2. So since it's 3/2, the 2 in the denominator is even. That's going to give me two solutions. I have x equals plus minus 8 as my answer. Okay? So that's the way of dealing with a fraction in the exponent. And now this last example actually has a good amount of work to it. We have the square root of 2x plus 12 equals x plus 2. Now it looks like a very basic problem, and it really is. You need to get rid of that square root, so I'm going to square both sides. But this is where the extra work comes into play. Okay? You have to remember, x plus 2 squared is not x squared plus 4. Okay? You need to make sure you are doing the FOIL or double distribute, but make sure you're multiplying both those binomials. Over here, this is easy. That cancels out to give you 2x plus 12. Over here, doing all that multiplying, you should get x squared plus 4x plus 4. And now you have a quadratic equation. Okay, so before we were simplifying stuff, it was giving us a linear equation. Now we have a quadratic. I'm going to bring some x value, my linear value, my constant value, bring them over. We have 0 equals x squared plus 2x minus 8. Double check my math there real quick. Okay. Now, you could look and try and factor this. Okay. You could try and use a quadratic formula. That's going to be up to you how you decide to simplify this, or how you decide to get your answers. This is a factorable equation, so you could factor this as x plus 4 and x minus 2. Set them both equal to 0. And there are your two solutions. You could do the quadratic equation. -2 plus minus 2 squared minus 4 times 1 times -8 divided by 2 times 1. So I'm simplifying here, gives us -2 plus square root plus minus square root of 36 over 2. -2 plus minus 6 over 2, simplifying that square root of 36. And now just -2 plus 6 divided by 2. That ends up giving us the positive 2. -2 minus 6 divided by 2. That gives us a -4. So either one of those methods gets us the same answer. Again, at this point, you need to be comfortable with one of the ways of solving a quadratic equation, especially if it's in standard form. Okay? Not every equation is going to be able to be factored, but every quadratic equation in standard form, I like the quadratic formula. It's usually my go-to because it's going to get you the answers no matter if they're rational or irrational. Okay? So that's the rest of 7.1. Solving equations, even if they have a radical or an exponent greater than 2.